Today we're talking about 6.3b, the second part of trig functions properties. We'll talk about odd versus even functions, right? So the definition of even functions is when if you put in a negative value for x, you get the same result as if it's the original f of x. So what that means is if you put in a negative value, you get the same output as if you had the positive value for x. For example, here I have, if my x is 3, I get 9, right? Because x squared. If I put in negative 3, I also get 9. So a positive value for x and a negative value for x gives you the same value for y. And when that happens, your graph is symmetric about the y-axis. That means that on the left and the right side of the y-axis, you get the same, well, it's symmetric, right? It's symmetrical. You fold the paper right in between here. The graph lies on it, on each other. So like that, right? It's symmetric, same distance on both sides of the y-axis. Odd functions is if you put in a negative value for x, you get a negative y. So negative input gives you a negative output. What that means is now if you have, you put in like, so if you have 3, or what is that? 1.5 basically, it gives you 2 here. Right? 1.5 for x gives you 2. Negative 1.5 will give you negative 2. Okay, so a negative value for x gives you a negative value for y. And when that happens, your graph is symmetric about the origin. So see what that looks like here. If you pick a random point and you go toward the origin, then on the other side, you have another point on the graph, exactly the same distance, right? So it's symmetric about the origin. And you pick any other point, yeah, like that. Like from here to here is the same as from here to here. And that's odd function. Remember, if you put a negative x, you get out a negative y. Whereas even function, you put a negative x, you get the same y. Now, when we talk about trig functions, remember if you have an angle, and then you got your triangle, and you get your x and your y. So if this angle is theta, let's see what happens, okay? So the trig function takes theta, and it gives you back like these ratio, x over y, opposite over hypotenuse, whatever. Now, if you have that negative theta, it would be down here then, right? So positive theta goes this way, negative theta goes down that way. So there it is. So you have a positive and a negative theta. When you have negative theta, the x stays the same, right? The x doesn't change. But the y now is down here, so it's the negative y. Right? Negative y. So let's talk about sine real quick. Sine of theta is y. What happens if you take sine of negative theta? Because theta is not the input, right? So theta is like your x. You put in a negative theta, you get a negative y instead. It changes. So negative x gives you a negative y. So negative input gives you a negative output. Then sine of negative theta is equal to negative sine of theta, which is, it gives you that sine is an odd function. Negative input gives you a negative output. So this is what you really want to remember. Sine of negative theta is equal to negative sine of theta. Okay. Now, if you want to look at cosine of theta is x, right? X over 1 is just x. If you do cosine of negative theta, it's still x because the x doesn't change the sign. Now, you have positive theta and negative theta, x is the same. So cosine, if you change it to negative input, your output doesn't change. So cosine of negative theta is still the same as cosine of theta. So cosine is an even function. So here is what you want to remember, the one in red. Cosine of negative theta is still the same as cosine of theta, whereas sine of negative theta is equal to negative sine of theta. Okay. So I have the two definitions up here for us to remember, and then we'll do some exercise. We'll rewrite these, and then we'll solve for them basically using sine and cosine. So you have cosine of negative 30, but cosine of negative is the same thing as cosine of that positive. So cosine of negative 30 is the same as cosine of positive 30, which gives you radical 3 over 2. The second part, I have sine of negative 135. Now look at sine of negative is equal to negative sine of the positive. So I have negative sine of 135, which gives you negative radical 2 over 2. Remember, sine of 135 is radical 2 over 2. And that negative sign here makes the answer negative. Cosine of negative 240, cosine of negative is equal to cosine of the positive. And that gives me cosine of 240 is negative 1/2. Okay. Now sine of negative pi over 3 is equal to negative sine of pi over 3, which gives you negative radical 3 over 2. Cosine of negative 2 pi over 3 is the same as cosine of 2 pi over 3. Remember, cosine negative doesn't change it, but sine negative of the angle gives you negative of the whole thing. So cosine of that 2 pi over 3 is negative 1/2. Now sine of negative 3 pi over 2 is the same as negative sine of 3 pi over 2. So I get 1. Because sine of 3 pi over 2 is negative 1. Negative of that gives you positive 1. So we're going to use that and we're going to find out the rest of the trig function. Which one's odd, which one's positive, which one's odd, which one's even. So here I have secant of negative theta. And that's, of course, equal to 1 over cosine of negative theta. But cosine of negative theta is just cosine of theta. So I have 1 over cosine of theta. So that means that secant now is equal to secant of negative theta is equal to secant of theta. So secant is even. It stays the same even if you have a negative theta. It's the same thing as you have that of a positive theta. So it's even. If you go to cosecant, you do the same, the same idea. It's 1 over sine of negative theta, which is 1 over negative sine of theta, because sine is different. Sine is odd, right? So sine of negative is equal to negative sine. That gives you negative cosecant of theta. So cosecant of negative theta is equal to negative cosecant of theta, which is an odd function. Okay. Everything else, tangent, is the same thing because of sine. The sign of negative theta changes, right? Negative sine of negative theta is equal to negative sine of theta. So if you have sine, it switches the sign of your original answer. So you have negative tangent of theta, which gives you, that's an odd function. Same thing for cotangent. You just flip it upside down. The sign is the same. So you get negative cotangent of theta. So it's also odd. So everything is odd except for secant and cosine. Right? Of course, because they're partners with each other. So let's do some exercise here. Now I have all these definitions listed on top here. You guys want to copy that down and save them, because you got to know this. Now, remember, now cosine and secant, these guys are even. The rest of them are odd. See, the rest of them you got to change the sign of the output also. If your input changes sign, the output changes sign. But for cosine and secant, you change the sign of the input, you get the same thing. So secant of negative 30 is equal to secant of 30 because it's even. It's one of the two that's even, cosine and secant. See? So you just do secant of 30, which gives you 1 over cosine of 30, which is 2 over radical 3, which then you have to rationalize, and you get 2 radical 3 over 3. And when you do cotangent of negative 130, well, that's equal to negative cotangent of 130. And cotangent is cosine over sine, so you do that, and you get negative radical 2 over 2 over negative radical 2 over 2, which gives you 1. Now, if you see cosine of 130, you got to know how to do that, right? Where's 130? You got to draw the angle, and you make the little triangle, and then cosine is adjacent over hypotenuse. You got to do all that to do this, right? If you still don't know how to do that, come to office hours. I helped a lot of people, understand that now. So you got to come and figure that out if you don't know how to do that still. Okay, now cosecant of negative 240. Cosecant is odd, so that gives you negative cosecant of 240, which is negative 1 over sine of 240, which is negative 1 over radical 3 over 2, and then you flip that and you rationalize it, you get negative 2 radical 3 over 3. Tangent of negative pi over 3 is negative tangent of pi over 3, which gives you negative radical 3 over 2 over 1/2. You flip and multiply, okay, and you get negative radical 3. Same thing with secant here, but secant is even, so you get this positive secant of, and then I simplify 4 over 6, which is 2 over 3. And that gives me 1 over cosecant of 2 pi over 3, which is 1 over negative 1/2, which gives you 2. The last problem here, I left as an exercise for you to try, but the answer is negative 3, radical 3 over 3. So that has to be rationalized. That was rationalized. So, work this out. Cotangent of negative of this is equal to negative cotangent of that. And then you do the whole ratio thing. You figure that out.